Before we proceed in solving problems applying the law of conservation of momentum, let's discuss first the collision. We have three types of collision. First one is the elastic collision, and we will use this PET simulation to illustrate or visualize how collision works. So for the elastic collision, we will use this Explore 1D tab. Okay, so in our scenario, we have two objects, 1 and 2, with a different mass and different velocity. So we'll check these values to see its momentum, initial momentum, and initial velocity, and also the kinetic energy so that we can observe if there's going to be changes in the kinetic energy. So elastic collision is one in which the total kinetic energy of the system after the collision is equal to the total kinetic energy before the collision. Or in simple word, the kinetic energy is being conserved or does not change after the collision. So we will observe here that the kinetic energy initially is 0.44 joules. And after the collision, let's do the simulation. Okay, so we could observe that the velocity and momentum of both objects change after the collision, but the kinetic energy still remain 0.44 joules. So what if we change the elasticity of the collision? Let's say, let's make it 50%. What would happen with our velocity, momentum, and the kinetic energy? As we can see, the velocity and momentum change after the collision. And the kinetic energy also decrease from 0.44 joules into 0.12 joules. Meaning, after the collision, there are kinetic energy that lost that may be transformed into heat energy or other kinetic energy such that cause the breakage after the collision. So what is an elastic collision? One in which the total kinetic energy of the system is not the same before and after the collision. So if the object, okay. So in simple word, our kinetic energy change after the collision or does not conserve. But take note, if we will consider the external forces be ignored and only the internal forces interact with our system, then we can assume a total momentum is being conserved. Thus, the law of conservation of momentum is applied in this scenario. Okay, so let's jump to our third type of collision. So in this case, we have two objects again with the same mass, but this time let's change the mass of object number 1. Let's make it 1.30. What would happen with our system after the collision? As you can see, after the collision, we have changes in the kinetic energy, meaning we have some kinetic energy being lost after the collision. And also, we can observe that the object 1 and 2 stick together. So this collision is what we call completely inelastic collision. So completely inelastic collision is when the objects stick together after the collision. So these ideas are important in solving problems in applying the law of conservation of momentum.